Can a rice cooker really smooth 3D prints? What about using sugar for better bed adhesion? Well, in this video, I'm going to be testing 5 of the wildest 3D printing hacks online to see which ones are great and which ones are garbage. Let's get started. How's it going, guys? Angus here from Muse, and I've been 3D printing for quite some time. And over the past 10 years or so, I've heard some ridiculous tips, tricks, and hacks that people have invented to get the most out of their 3D printer. But I've always wondered, do they actually work? Well, there's only one way to find out. But first, a quick disclaimer. These ideas range from weird to outright dangerous to you or your 3D printer, so I take no responsibility should you attempt any one of them. This video is for educational purposes. I am testing them so you don't have to. Number 1. Smoothing ABS prints using acetone and a rice cooker. This trick goes way back to the beginning of this channel and one of my first ever videos. I used to print on demand and I was trying to find an easy and repeatable way of making my 3D prints look more professional. Because let's be real, those layer lines look pretty bad. Acetone is a solvent that dissolves ABS plastic, which was the primary filament I was printing with at the time, and I was already using it to solvent weld my prints, but you couldn't just dip parts into the acetone because it would melt and destroy them in seconds. However, somewhere on the internet I read that acetone could be heated to create a dense vapor which would melt just the outside surface of ABS parts, where it would then evaporate off, leaving a smooth, glossy finish behind. And what's a good cheap source for that heat? Well, a rice cooker. I made a tutorial with my method, uploaded it to YouTube, and 12 years later, I find myself needing smooth parts once again. So let's give it a shot and see if it's still worth the effort. To do this successfully, the filament must be able to be dissolved in acetone or it won't work. ABS is the most popular, but in theory, HIPS should also work, so I'm going to give that a go as well. And there are many different approaches to doing acetone vapor smoothing, but for this process, I like to keep the parts cool and dry, and then I submerge them into the warm vapor for only a few seconds, which causes the acetone vapor to condense onto the outer surface of the part. Suffice to say, this is a process you'd want to do in a well-ventilated area or outdoors, well away from any open flames or sparks, because acetone vapor is flammable, and you also don't want to breathe it in. I set up in my garage with the door open, and I did try to explain what I was doing, but between the respirator and the birds outside going nuts.
Okay, so I'm sure you can understand perfectly, so let's give this a go.
Yeah, let's stick to the voiceover. I measured out a shot worth of acetone and poured it into the rice cooker before turning it on to cook. From cold, it took about a minute for the acetone to start to boil, but the rice cooker will just keep getting too hot. Acetone has quite a low boiling point, so at this point, I just turned it off. You can see the vapors starting to condense on the cold lid, which means it's formed a vapor and it's ready to start vapor smoothing. I tried the HIPS print first, and you can see the acetone condensed on the surface almost immediately, and it melted a little, but it didn't seem to do all that much to the print. So I put it aside to dry, and I did the ABS part next, topping up the acetone just a little because the vapors do get used up each time. Once again, you can see just how quickly the vapors coat the print, but in this case, they began to melt it immediately. It's also worth noting that this roll of ABS has been sitting open in my garage for over 7 years, and it printed perfectly fine with no issues. ABS just doesn't seem to suffer the moisture absorption issues of other filaments, so long as you keep it out of sunlight, so that's good to know. When I was happy with the result, I killed the power and then removed the rice bowl itself from the machine, which causes it to quickly cool down and stops the acetone from boiling and creating unnecessary vapor. Straight after the vapor bath, the parts are incredibly fragile and sticky. If you touch them, even gently, you'll leave a mark and damage the surface. I generally found that they needed a good 24 hours or so before the acetone in the plastic evaporated away and the surface would harden again. Acetone vapor smoothing using a rice cooker is the literal definition of a 3D printing hack. It's no magic bullet. The layers that were smoothed the best were the finely stacked vertical surfaces, and the sloped surfaces still have visible stair stepping. But when it does work, it works remarkably well, for the actual amount of effort involved. However, there is no way I can recommend anyone do this. Acetone is not the most toxic of the solvents, but you shouldn't touch it or breathe in the vapors, and I also mentioned it's flammable. There is way too much that could go wrong when doing this process. And that's not to mention that acetone smoothing is also an averaging process. You don't really have control over what it will smooth. For example, you lose all your hard edges, and as such, it will ruin dimensional accuracy of your print. Since coming across the rice cooker method over 12 years ago, there are now slower and somewhat safer methods that people use for vapor smoothing, like this one, using a large plastic container demonstrated by Prusa. But honestly, how many people even print with ABS these days? Because here's the kicker, acetone will not affect PLA or PETG. The process does nothing to these materials. And please don't get any smart ideas of replacing acetone with another solvent that may melt these plastics, because some of those can really mess you up. So acetone vapor smoothing may be a process best left in the past, but how about one you can use right now to create prints like this? Enter hack number 2, 3D printing onto fabric. This trick involves pausing a multi-body print partway through and then stretching a porous fabric over the top of it. When you restart the print, the next layer melts plastic down through the holes in the fabric to permanently bond it into place. So once the print is complete, you're left with a complex, flexible print that can be used for fashion, cosplay, or whatever else you want. To give this hack a go, I created this hexagonal array of spiky parts. Each body is only 12mm across, so it's very small, but the idea is that they'll combine into the final print to create a complex textured surface. I thought it looked a little too uniform, so I cut out all the bodies with this spline-driven loft to add some nice variation before exporting all the bodies as one 3MF file for slicing. I opted for the Prusa XL for this experiment because it's got a huge print volume and I can easily swap tool heads towards the end from black to a red PLA to get this striking effect. And the magic comes from adding a pause in the G-code preview window in the slicer, but you only add it a few layers into the print. So in theory, this gives the print enough time to bond securely to the print bed, and then with the pause, you can then place the fabric over those first few layers and resume printing, which sandwiches the fabric into place with molten plastic. And for that fabric, you need something with holes in it so the molten plastic can key into it and bond to the previous layer. I dug through my stash and found this rather delicate mesh, which I think is the same kind they use for tutus. I'm not planning to make one of those anytime soon, so I cut a square off to use. The Prusa XL is huge, and mine currently lives under the workbench, so it was a little tricky adding the fabric during the pause, not to mention the fact it was all scrunched up, and I did initially try using painter's tape to hold it down, which worked okay, but it didn't have a great amount of stick to the heated print surface. Still, you only really need it to stick for that next layer, because once it's bonded in place, it's not going anywhere. Unfortunately, the resume function as it currently stands just slams the nozzle back to the start of the next layer with no Z-lift or pre-extrusion, so that kind of sucks, but thankfully it didn't seem to ruin anything and it began printing over the mesh. And after a few hours, it was complete, and this is the final result. If you're into the fidget toys or articulated dragons that are all the rage right now, you have to try this out. It is so satisfying to play with, and it really does flex and conform to surfaces the same way that fabric does. This hack has been used by cosplay creators for ages, and I can see why, but I would definitely use a stronger mesh than I did. This stuff bonded really easily, but it's pretty fragile, and I could see the whole assembly tearing in half if it got snagged. But then I wondered, what if the backing was a lot stronger? Could you use this technique to add reinforcement to print in a similar way to how carbon or Kevlar is used? Well, I don't have any Kevlar weave on hand, but I did find this nylon fly screen, which is far stronger than the tutu material. And for this experiment, I sliced my chassis for Violent Crumble, my tiny plastic combat robot, to be printed with a 95A TPU with a very sparse infill. This is a print that is designed to flex, and this is very old wet TPU, so disregard the surface finish, but you can see how flexible it is without any of the reinforcement. However, for this experiment, I added 2 pauses, one after the first 3 layers, and then a second one right at the top, below the first few solid layers. This creates two planes of the nylon fly screen separated by an air gap, all incorporated into the TPU print. And for this test, I also opted to use magnets to hold the fabric down. A big thanks to Teresa for suggesting that one over on Patreon. It worked a treat for both layers, and it was really satisfying to watch the molten TPU bond over the fabric material. Once the print was complete, the next step was to cut away all the excess material, and this proved way harder than I expected. Scissors work totally fine for the larger parts, but the mesh is so tough that a box cutter had a really hard time getting through it, and I eventually just kind of gave up. Still, you'd think that bodes well for its resilience during impacts. However, after all of this effort, the results are somewhat underwhelming. The prints feel slightly different, with the reinforced print bending and buckling slightly less easily, but they both have the same degree of flexibility, and unfortunately it seems the same amount of resilience. A pair of side cutters made easy work through both prints. It was as if the nylon mesh wasn't even there, and I resorted to a brute force test to try tearing the print, and it just caused the nylon mesh to tear alongside the TPU. When it comes to these materials, I think most of their resilience actually comes from the fact that they can deform and spread the load out, but when it's fused in place like this, it's only really thin nylon strands that can easily break when they're locked into the matrix of the plastic. I'm not giving up on that idea yet, but it does need more experimentation. However, should you try 3D printing on fabric? Yes, absolutely. It's a ton of fun, but I would say only really do it for aesthetic reasons unless you figure out a better way to incorporate the stronger mesh. Hack number 3, you can use sugar water for print bed adhesion. Yes, I promise you, I did not make this one up. Sometimes prints just don't want to stick to the print bed, and this is especially true with filaments prone to warping, like ABS. And this is a large reason not many people print with ABS these days. It's a pain to stick down. But what if you could stick it down using sugar water? I'm not kidding. This is a hack that's been circulating on the internet for years, and I always thought it was pretty ridiculous. But sugar is a lot cheaper and easier to get than purpose-made bed adhesion helpers, so let's try it out. For this test, I threw a simple rectangular bar into Orca Slicer and printed it out on the Bambu Lab A1 with its powder-coated PEI print surface. I ran the default printing temperatures for ABS, but I upped the perimeters to 3, and I used a 15% density cubic infill, which should make for a strong part, provided it can stay sucked down. Test 1 was the Control, a perfectly clean print bed, which I washed with warm water and dishwashing liquid to remove any oil, dirt, or previous bed coatings. And surprisingly, the print started out great. But unfortunately, as it got to the final top few solid layers, disaster. It came free from the print bed, and I found it on the floor next to the printer. So let's see if sugar water can make all the difference. I wasn't sure how much sugar to dissolve into the water, so I started with roughly 2 tablespoons into around 100 milliliters of water, using a sports drink bottle to shake it up and dissolve it all, which I thought was quite fitting. I then applied this liquid to the heated print bed to speed up the water evaporating and spread it around, repeating a couple of times until I was left with a slightly sticky surface. It really does feel sticky, so I was quite hopeful, and the print started out great, but just like before, disaster. I added even more sugar to the solution and had another go, but I got much the same result. I even tried honey. I mean, it's mostly just sugar, so I figured out it should do the same thing, but it actually got thinner as the bed heated up, and it provided so little adhesion that the print failed pretty much straight away. So I wiped it all off, started fresh, and in desperation, I carefully poured the sugar solution onto the print bed and heated it to 100 degrees Celsius to see just how much of a sugary coating I could get onto it. As it turns out, quite a lot. Basically, I was making toffee with a 3D printer. And this thick, sticky mess was way too much. The prints were actually getting worse. So maybe there was a sweet spot between too thin and too thick. Pun absolutely intended. And finally, after way too many tests and a table full of sticky failures, the print completed and it didn't come off the print bed. But calling this a successful print would be very generous. It looks absolutely awful with significant warping on one side. Maybe if I was a little bit more careful, it could have been improved a little, but yeah, no, I do not recommend this. Even if sugar water did work, do you want ants? Because this is how you get ants. As a sanity check, I cleaned the print bed one last time and gave it a spritz with this bed adhesion spray from Filiform. This is their extra strength version. Not sponsored in any way, they sent this to me ages ago to try out, and well, yeah, it works really well. It stuck the ABS print down with no issues at all, and once the print's complete, you can actually hear the print cracking free from the bed as it cools and contracts. But if you want to print ABS or filaments that warp, this is still not the right solution because the part will still warp, if not on the bed, then higher up. You need a chamber with high ambient temperature to print ABS with any degree of dimensional accuracy. So that's the real hack here. Keep the ambient temp high with an enclosure or use a printer that is enclosed. As long as your printing surface is clean and suitable for your filament, you'll have no problems at all with bed adhesion. Hack number 4. You can now get your 3D prints made from metal, and it's easier than you might think with this video's sponsor, PCBWay. Okay, but seriously, just take a look at this part. This is 3D printed from tool steel using a process called DMLS, or Direct Metal Laser Sintering. Metal printing processes are a mature technology which fuse together a fine metal powder using a laser within a heated chamber that's flooded with an inert gas. These machines are set up in purpose-made explosion-proof rooms because of the fine metal powder they use. It is not something you would ever own at home, but it is something that PCBWay has been making accessible for years now. With PCBWay, you can choose from a wide range of processes to make your ideas a reality, from CNC machining to laser cutting, PCB fabrication, and 3D printing on industrial 3D printers. To use their services, all you need to do is export your design as an STL, 3MF, or STEP file, and then upload it to their quoting engine. From here, you can choose the material you want to use, as well as its finish and any specific requirements you might need. Your part will then be looked over by a real engineer who will then make sure it's manufacturable using your chosen process before then being made and shipped right to your door. So why not give PCBWay a go for your project? You can use code PCBWay-MakersMuse-10 for $10 off any order of $30 or more. You can find more information in the video description below. Big thanks to PCBWay for sponsoring this video. I remember first hearing about metal 3D printing way back in university when CSIRO here in Australia were using an RCAM electron beam 3D printer to fabricate titanium shark tags as part of a shark tracking project. I remember thinking just how incredibly cool it was, but the idea of getting parts made in metal was so far out of reach for a lowly uni student at the time. And also the parts looked very, very rough. They hadn't quite nailed the particle size and particle uniformity that you need for an accurate metal 3D print that you can now get today. It's incredible how far we've come, and I'm actually seeing metal 3D printing creep into combat robotics as well, because you can use it to create parts that just aren't possible any other way. Super cool tech to know about. Number 5, you can release stuck TPU prints using IPA. If you've ever printed with flexible filaments, then you'll know just how well they can stick to the print bed. They're like the opposite of any other filament. Most filaments prefer a perfectly clean heated print surface and they pop free once it cools. But if you print TPU directly to that very same surface, it can stick way too well. In fact, it can effectively weld to it. And I have, no joke, destroyed flexible prints by trying to rip them off the print surface in the past. This is why I've always advocated for putting a thin layer of glue stick onto the print bed when you're printing with TPU, because it actually acts as a release agent to help the print come free afterwards, and it's a habit that's been reinforced by those horrible moments of ruined print surfaces. However, sometimes I'm lazy and I forget, and I end up with prints like this, hopelessly stuck to the print bed. And that's when I remembered the internet tells me that I can release these TPU prints with isopropyl alcohol. Apparently, you can spray isopropyl alcohol or methylated spirits onto the base of a stuck TPU print, and it will magically release. This only came across my radar recently, and I have my doubts, so let's find out. So, let's see if a quick spritz of isopropyl alcohol will do anything to it. No way. No way. That's freaking incredible. Alright, how about the print? Get a bit more under there. But I don't think isopropyl actually damages TPU, so I'm just dousing it. That's crazy. That is crazy. Wow. Alright. That worked a treat. Because, like, just, yeah, so this hasn't been sprayed, and it barely comes off. And that's just going to evaporate, and the plate's good to go. That's an awesome trick. Isn't that awesome? For something that's so simple, this has revolutionized how I remove TPU prints from my print bed, especially foam TPU, which is so fragile it's very easy to rip the print in half if it doesn't come free. I have no idea how this actually works, whether it's a chemical thing or a temperature thing from the IPA wicking between the first layer and the print bed through capillary action, but I love this trick. Thank you, whoever recommended it to me in the comments section. I apologize for doubting you. Do you know a 3D printing hack you'd love to see tested? Let me know in the comments below, because I know a lot more of super weird ones, and I'd love to do a part 2 of this series if there's enough interest. A big thanks to PCBWay for sponsoring this video. You can check them out in the video description below, and I'll catch you again very shortly here on Maker's Muse. Bye.